So there are two types of problems can come in measurement. One is accuracy related problem. Another one is precision related problem. The accuracy related problem you can understand by using three terms. One is bias, another one is linearity, another one is stability. And one more kind of problem that can come is precision related problem. What is precision related problem? Am I measuring consistently? The accuracy answers the question, am I measuring correctly? Precision answers the question, am I measuring consistently? When I ask you to measure multiple times, same part, you are measuring multiple times. Will you get same readings? If you get same reading, then you are precise. If you are not going to produce the same reading, then you have a precision issue. So there are two types of error. One is accuracy error, another one is precision error. Accuracy you can solve, accuracy related problem you can solve merely by calibrating the gauge. But precision, there is no specific solution. You have to analyze and then solve it. And that is what we are going to understand in this session. So you must have a very good data collection plan, because whenever you want your team to do something, easily they can do it wrongly. Whatever you are telling, it is very difficult to get people falling in line. You are telling them to measure it in a particular way. Do you think they will measure in the same way? No, they will measure it in their own way. As a result, your reading will have error. Isn't it? If there are 10 people who are collecting the data, all 10 people should collect the data in a same way. Then only all 10 of them will give the same reading. So data collection plan should be sound. And then the bias, linearity, and stability, Dr. Ravi has taught you. And I'll be covering the gauge R&R part. What is gauge R&R? The repeatability and reproducibility. All right. Right. So when I expect my team to collect the data, what is most important? I should give them a clear operational definition. I should give them a clear operational definition. When somebody reads the operational definition, he should understand correctly, and then you should do it the way it is expected. A clear, concise statement about what do you want to measure. See, easily things can go wrong in any company. So let me show you a video. This will help you understand how people can measure wrongly by misunderstanding the instruction. So this is a funny video I received in my WhatsApp. So let me play it.
Okay, double click on my computer. I can error.
Right. That's all. You have understood the problem?
Yes, sir.
Will you have such a member always in your project team?
Yes.
Definitely. If you tell something, he'll measure something and then give you an irrelevant data. And irrelevant data will be useless for any analysis. So you have to be very, very careful with such a team member. And also there are other reasons people measure wrongly. So you should always have give them a clear statement. For example, I want you to measure diameter. My rod is 200 mm length. Where should I measure the diameter? Should I tell you or not? You should measure the diameter at the edge or at the center, or you need to measure at all the points and take the average? Is that instruction required or not? Definitely required. If I don't tell you, then if there are 3 people, 4 people who are collecting the data, each one will collect the data in their own way, and finally your data will go wrong. So as Ravi has taught you, there are types of data which you must master. There are 2 types of data. One is qualitative data and quantitative data. What is qualitative and quantitative data? If I ask you, what is your name? Is it a qualitative data or a quantitative data?
Qualitative.
Your name is a qualitative data. What is the brand of the laptop you are using? That is also qualitative data. I am asking you, what is your age? That is quantitative data. I want to know your height. That is also quantitative, right? So now you broadly understand what is qualitative and what is quantitative. And within quantitative, you have two types, discrete and continuous. Both are numbers only. Both are number format. Discrete means countable. Continuous means measurable. Ravi also highlighted this. Number of people who are attending the meeting. There are 23 people right now. How do you say it is 23? You counted. Number of students in the class. You counted. The number of parts that is rejected in your company. That is a countable data. All countable data are discrete data. Discrete data will be always whole numbers. Discrete data will be always whole numbers. Can you say rejection is 1.5 parts? Not possible. Rejection is either you reject one part or you reject two parts. Am I right? And number of people attending the meeting, it is 23 or 24. Can I have 23.5 people attending the meeting? Yes or no?
No.
Not possible, right? So discrete data are always whole number. We call it discrete because within the preferred range, only fixed values are possible. For example, when I want you to give a score for our training program, 0 to 10, you will give only some fixed numbers. Either you will say 1, 2, 3, 4 or up to 10. So how many values are possible? Only 10 values are possible, isn't it? And nobody is going to give me, the training score of 9.784. Yes, no, they are not going to give it that way. It is only the round numbers are possible. Only the fixed values are selected within a particular range. Such data are called discrete. If any value can come within the range, then it is continuous. For example, I want to measure, the dimension of a product. I am producing the product from 10 mm to 12 mm. And between 10 mm to 10 mm and 12 mm, how many possible values are there? When I measure between 10 mm and 12 mm, how many possible values can come? Come on, tell me some value. Between
20.
10 and 12, 20 value only come. Why not? Why only 20? Is it 10.1 possible? Yes or no?
Yes. Yes, sir.
10.1 is possible, 10.2 is possible, 10.15 is possible, 10.154 is possible. Am I right? There is no end. It is endless. That is why we call it continuous data. Do you understand why we call it continuous data? It will have decimals. Between any small range, you will have infinite number of values. Such data are called continuous data. Tell me the income tax you pay every year. Is it a continuous data or a discrete data?
Continuous.
It can be any number, right? You can't say it is only this number. So it can be any number. So it is continuous. So let me check whether you have understood correctly or not. Width of a sheet. Width of a sheet, is it a continuous data or discrete data?
Discrete.
Width of a sheet. Do you count the width? Will you count the width or measure the width?
Measure the width.
Then when you measure it, what is it called?
Continuous data.
So width of a sheet is continuous data. Number of liners thinned.
Discrete data.
Number of tubes rejected.
Discrete.
Diameter of a piston.
Continuous data.
Height of a man.
Continuous data.
Sheet thickness.
Continuous data.
Continuous.
Out of 100 sheet, the number that meet the thickness 4 plus or minus 0.9.
Discrete data.
Time taken to process a purchase order.
Continuous data.
Time taken. Time is a continuous data or discrete data?
Continuous data.
Continuous.
Time is measurable. Number of bugs in a software program.
Discrete data.
That's all. You have understood the difference between continuous data and discrete data, why it is required. Then only you can select the tools correctly, particularly the statistical tools, right? So for you to master the art of measurement, how to measure, you should have clarity on all these things. So at the elevate level, we are not going to talk about everything, but we'll give you a broader view, right? You understood bias, you understood stability, you understood linearity. Do you know what is resolution? Resolution is nothing but the least count. Resolution is nothing but the least count. And yesterday, did you check the least count of the stopwatch in your mobile phone? Can somebody tell me what is the least count in the stopwatch of your, the digital clock in the smartphone?
0.01 seconds.
0.01
second.
Millisecond.
Millisecond.
0.01 second. 0.01 second, I agree, but I don't agree millisecond. What is millisecond?
0.001.
1 by 1000 of second is millisecond. When you say 0.01, it is not 1 by 1000. It is 1 by 100. Every second is divided into 100 parts, and each part is called centiseconds, not milliseconds. 1 meter, when you divide into 100, each part is called what? Centimeter, right? Similarly, 1 second, when you divide into 100, it is called 1 centisecond. Either you say 1 centisecond or 0.01 second. Both are correct. Beautiful. So that is resolution. And repeatability and reproducibility. What is repeatability? When I ask you to measure a part, 10 times I want you to measure the same part. The part is same. Equipment is same. Instruction is same. If you give me all 10 readings exactly same, then you are repeatable. But actually, when you ask your appraiser to check the 10 parts 10 times repeatedly, but you should not let him know that he is checking the same part. You have to keep it confidential. All of you understand what I'm saying? The person who makes the measurement, he should not be informed that he is measuring the same part repeatedly. How he will measure? He will give 10 different reading. Am I right or not? Same part, he measured 10 times, but readings are different. Now the error committed is called repeatability error. Similarly, if there are multiple operators involved, for example, I am measuring, I am saying that it is 100 mm, and same part you are measuring, and you are saying that it is 110 mm. Now we are disagreeing to each other, but both of them are working in the same company, measuring the same part, using the same gauge. Instructions are same, but what I am saying 100, what you are saying 102 or 110. Now, is there a disagreement? What is the disagreement? 10 mm. So that disagreement is called reproducibility error. That disagreement is called reproducibility error. All of you understand what is repeatability and reproducibility?
Yes,
Yes,
sir.
sir.
Tell me what is repeatability error, one of you. What is repeatability error?
It's like same person repeating the measurement with the same part. And the reproducibility is miscalculation between 2 or 3 other persons.
Very good, beautiful. So the inconsistency within the appraiser is called repeatability, and inconsistency between the appraiser is called reproducibility. You call it inconsistency or variation, right? Variation is the problem everywhere. So when you don't understand that these many types of errors are possible, you might sometimes fail to correct the error. See, when you are driving a car, your focus should be on the road. Am I right? When you see the road continuously, now you drive safely and then you reach the destination on time. Suppose if the road is not visible, will you be able to drive the car and reach the destination on time? Tell me.
No.
Not possible. Same way, when you want to solve the problem, you must continuously see the problem till you solve it. Then only you will know, reach the milestone, you will reach the result. But how do you see the problem in your company? Is that the problem will be explained in the TV channel? No. You have to collect the data and understand, isn't it? How big is the problem, or how small is the problem? So when you collect the data or by committing a measurement error, you will not be able to see the problem correctly. So measurement error will not allow you to see the problem clearly. So that is why it is very important. We try to control, we try to eliminate or at least control the error, and thereby we will be able to see the problem. It's like, suppose you are driving the car. If it is raining, what will happen? The water droplet will hide the road. Now what will you do? You switch on the wiper. When you switch on the wiper, it will clean the windshield, and now you will be able to see the road. Same way, when measurement error pours, you must wipe out the measurement error. For wiping out the measurement error, the tool to be used is gauge R&R. Gauge R&R means gauge repeatability and reproducibility. So repeatability is the error within the appraiser, and reproducibility is error between the appraiser. And now let us do an activity, and then we'll understand the repeatability error and the reproducibility error. So all of you, please, you can come on video, and you can take your smartphone. Take your smartphone and keep the stopwatch ready with you. So all of you have to use. So keep your stopwatch ready. And all of you told me that the least count of your stopwatch is 1 centisecond, right? Or 0.01 second.
But sir, I have the stopwatch with millisecond.
Oh, right, no problem. You can still measure it. Measure it.
Okay.
And give me the reading. I will take up to centisecond. The third decimal I will ignore. All right.
So can you repeat once?
No, you have to measure using your the stopwatch in your smartphone. And what we are going to measure, I will explain the operational definition. Don't make it like my computer, right? I will explain. I will be playing a song from my side. I will be playing a song from my side. The moment I play the song, you can hear it. Am I right?
Yes, sir.
Once you hear it, I want you to switch on your stopwatch. Then the song will end automatically. As the song ends automatically, what you need to do? You have to stop the stopwatch. Clear? Now
Yes,
your
sir.
stopwatch will give you the reading. That reading, I will collect it. Is that instruction clear? Operational definition is clear?
Yes, sir.
Yes, sir.
Beautiful. So ready for the first song, right? Yes. Shall I play?
Yes, sir.
3, 2, 1, and here we go.
Human error. Reproducibility.
Reproducibility error. See here, multiple appraisers are involved. And there is an inconsistency. The reading given by Mayank is different from reading given by Vignesh. And again, the reading of Darshan differs from others. Same way, you are not agreeing to each other. All of you are working on the same project. All of you are on the same team. All of you were given the same instruction. But when it comes to measurement, you are disagreeing to each other. That disagreement is called what? Reproducibility error. And now move on. We are moving on to the next reading. All of you are ready again?
Yes,
Shall we measure? We go for the second reading. That means the second song. This is a Tamil song.